So let's say that y is equal to x squared sin of x. So we have two terms that are multiplied together and we want to differentiate this whole thing here. And we can do this using the product rule. So the product rule is that if y is equal to uv, then dy over dx is equal to u and then dv over dx plus v and then du over dx. So the best way to explain this is to do this example here. So hopefully you can see that y is equal to x squared sin of x is of the form y is equal to uv. It's two terms multiplied together. Here it's u multiplied by v, and here it's x squared multiplied by sin x. So therefore u is equal to x squared and v is equal to sin x. Now, I just want to quickly remind you what this terminology means of dv over dx, du over dx, and dy over dx. We also talked about this in the previous video on the chain rule in this chapter. It's really simple. The thing on the top is what we're differentiating, and the thing on the bottom is what we're doing it in terms of. So if we focus on the u is equal to x squared, if we differentiate this, it's going to be du over dx. So the thing on the top, the u, this is what we're actually differentiating. So we're differentiating the u here. And the thing on the bottom, the x, this is what we're doing it in terms of. So we're going to be differentiating x squared in terms of x. And if you differentiate x squared in terms of x, this is just going to be 2x. So du over dx is 2x. And if we focus on v is equal to sin of x, and we differentiate this, it's going to be dv over dx. The thing on the top, the v, this is what we're differentiating, so we're differentiating the v. And the thing on the bottom is what we're doing it in terms of, so we're doing it in terms of x, so we're differentiating sin of x in terms of x. And we talked about in the first video in this chapter that when you differentiate sin of x, you get out cos of x. So dv over dx is cos of x. So therefore dy over dx is going to be equal to, and then we just plug the values into here. So it's going to be u, which is x squared. U is x squared, so it's x squared, and this is multiplied by dv over dx, which is cos of x. So this is multiplied by cos x, and this is plus v, which is sin of x, and this is multiplied by du over dx, which is the 2x, like this here. And therefore dy over dx is going to be equal to x squared cos of x plus 2x sin of x. So with the product rule, as this is a plus here, these can actually be swapped around. You can actually write it in any order, such that it doesn't actually matter which one you call u and which one you call v. You could also do u is equal to sin x and v is equal to x squared and do the exact same process, and you'll get the exact same final answer. They're interchangeable, it doesn't matter. Such that this makes the product rule very easy to use. All you need to do is, if you have something like this where you have two terms that are multiplied together and you need to differentiate it, you just call one of them u and one of them v. Again, it doesn't matter which one, and then it is just dy over dx is u multiplied by the derivative of v plus v multiplied by the derivative of u. It's very simple, and you just do it like that. You just name one of them u and one of them v. So here's two more examples of when we need to differentiate using the product rule. So for this first one here, we have y is equal to the natural log of x multiplied by sin of x. So we have two functions that are multiplied together, so we have to differentiate using the product rule. And as I mentioned before, it's interchangeable which one you call u and which one you call v. It's whatever way around you like. So I'm just going to say that u is equal to the natural log of x, so therefore du over dx is equal to, and when you differentiate the natural log of x, we talked about this in the first video in this chapter, you get 1 over x, like this here, and then therefore we call v the sin x, so therefore dv over dx is equal to, and if you differentiate sin of x, we've already talked about it in this video, that you get cos x. So dy over dx is equal to, now when you're writing out dy over dx, you multiply u by the opposite derivative, so it's dv over dx, and it's the same with v. You multiply v by the opposite derivative, which is du over dx. So dy over dx is going to be u multiplied by dv over dx, so the natural log of x multiplied by cos of x, so it's going to be the natural log of x cos of x, like this here, and then this is plus v multiplied by du over dx, so sin of x multiplied by 1 over x, which is going to be sin x over x. So dy over dx is equal to the natural log of x multiplied by cos of x plus sin x over x. And then for this second one here, y is equal to 3e to the power of x multiplied by cos of 4x. So we have two functions multiplied together like this here. Now, when you have a coefficient in front of the thing that you're trying to differentiate using the product rule, there's two ways that you can approach this. One, you can include this coefficient in one of the functions that you differentiate. So you can say that u is equal to, rather than just e to the power of x, you can say it's equal to 3e to the power of x. Or the second way you can approach it is kind of just ignore this number for now and then differentiate this here using the product rule. And then when you're writing out dy over dx at the end, just remember to multiply the entire thing by 3 like this here. I personally prefer this first way here, just because if you do it the second way, there's kind of a risk of you kind of forgetting to multiply it by the 3 at the end. So therefore, if you just do it like this, there's no way that you'll be able to forget, as you've included it right at the start. So I do it this way here, and then du over dx is equal to, so when you differentiate something that has a coefficient in front of it, this coefficient just comes down, so it's going to be 3 multiplied by, and then when you differentiate e to the power of x is still going to be e to the power of x, so therefore du over dx is going to be 3e to the power of x. There's no change. And then we say that v is equal to the cos of 4x, so then dv over dx is equal to, now when you differentiate something like this, you need to do two things. Firstly, you need to change the cos for the minus sin, or if it's the sin for the cos. And two, if you have a number inside the trig function like this here, we have 4, this needs to come down as the coefficient as well. So when we differentiate this, we need to swap out this cos for minus sin like this here, and then this 4 needs to come down as the coefficient, so this becomes minus 4 sin like this here, and then inside this trig function it's still going to be this 4x like this here, so dv over dx is equal to minus 4 sin of 4x, so therefore dy over dx is going to be equal to u multiplied by dv over dx is going to be 3e to the power of x multiplied by minus 4 sin of 4x, and then this is plus v multiplied by du over dx, which is going to be cos 4x multiplied by 3e to the power of x, and then we can simplify this because 3 multiplied by minus 4 is minus 12, so dy over dx is equal to this here. Now I just want to exaggerate the difference between the product rule and the chain rule. We use the product rule when there are two functions multiplied together like this here and like this here. We use the chain rule when there is a function inside another function, and go back to the chain rule video I made before to see examples of that. Now, it's very common for them to combine the product rule and the chain rule into one question. So here's some examples of these. So for this first one here, we have y is equal to x squared and then the square root of x squared plus 2. Now, when we're differentiating a square root like this here, it's always easier to write it in the indices format of to the power of a half, like this here when we're differentiating. And then this here, we need to use the product rule because we have two functions multiplied together. We have this x to the power of 2 and this x to the power of 2 plus 2 to the power of a half. So if we say that u is equal to x squared, then du over dx is equal to 2x when we differentiate this here. So therefore v is going to be equal to this other function, which is this x squared plus 2 to the power of a half. So if we differentiate this to dv over dx, so for this we need to use the chain rule. Now I'd recommend going back to the chain rule video if you need a reminder of how it works and when we use it, but we use it when we have a function inside another function, and in this case we have this. So the chain rule, there's a quick way to do it and a long way to do it, and I'm going to go through the quick way. And the quick way is that the chain rule is equal to the inner function differentiated multiplied by the outer function differentiated. And if we look at this x to the power of of 2 plus 2 to the power of a half. The inner function is this x squared plus 2, and the outer function is this power of half here. So therefore the chain rule is the inner function differentiated, which is going to be this x squared plus 2 differentiated. So if we differentiate this, it's going to be x squared differentiated, which is going to be 2x, and if you differentiate plus 2, it's a constant, so it just goes away. So the inner function differentiated is just this 2x here, and then this is multiplied by the outer function differentiated, which is going to be this power of half differentiated here. And when you differentiate a power of half, you can kind of think about this as like x to the power of half if you differentiate this here. So this half is going to come down as a coefficient, so it's going to be like this here. Now, when you differentiate the outer function, we went through this in the chain rule video, you have to keep the inner function constant. So this here is still going to be x squared plus 2 like this here, and now it's going to be to the power of a half minus 1 like it was x to the power of half differentiated, so it's now going to be to the power of minus a half like this here. And we can simplify this because this 2 is going to cancel out with this 2 here, so we're left with x over the square root of x squared plus 2, as this power of minus a half here, remember, is 1 over the square root of x squared plus 2. So dv over dx is equal to this here. So therefore dy over dx is going to be u multiplied by dv over dx, which this x squared is going to multiply this x here, so it's going to be x to the power of 3 over the square root of x squared plus 2, and then this is going to be plus v multiplied by du over dx, so it's going to be 2x multiplied by this x squared plus 2 to the power of a half, which can be written as the square root of x squared plus 2. So this is dy over dx. And then for the second example, we have y is equal to 4 cos of x multiplied by the natural log of x to the power of 3 minus 3. So we'll say that u is equal to 4 cos of x, therefore du over dx is equal to, and then when you differentiate cos, you get minus sin, so this is going to be minus 4 sin of x like this here, and therefore this will leave v is equal to the natural log of x cubed minus 3 like this here, and then dv over dx is going to be, so we need to use the chain rule on this. The inner function is this x cubed minus 3 and the outer function is this natural log. So the chain rule is the inner function differentiated, so this differentiated here, so it's going to be x to the power of 3 differentiated, which is going to be 3x squared, and then this constant just goes away here, and this is multiplied by the outer function differentiated, which is this natural log. Remember, when you differentiate the natural log, it becomes a 1 over kind of fraction like that here, so it's going to become 1 over and then the x cubed minus 3. Just a reminder, when we differentiate the outer function, so the natural log, this inner function just remains constant, and it's just going to be the x cubed minus 3 here like this, and then if you multiply this, this will come in the numerator, so it becomes 3x squared over x cubed minus 3. So therefore dy over dx is going to be u, which is 4 cos of x, multiplied by dv over dx, which is just 3x squared over x to the power of 3 minus 3, and then this is plus, and then it's going to be minus 4 sin of x multiplied by the natural log of x cubed minus 3. We can simplify this. 4 times 3 is equal to 12, so it's going to be 12 x squared cos x over x cubed minus 3, and then this plus and minus will cancel out to just give a minus 4 sin of x, and then the natural log of x to the power of 3 minus 3. So this is dy over dx. Okay, so here's some more examples. So for the third one, we have y is equal to sin squared x multiplied by cos squared x. I talked about this in the chain rule video. It might be a bit easier to write this as sin x to the power of 2 multiplied by cos x to the power of 2, because it's a bit easier to understand when we're doing the differentiation. So we're going to use the product rule because we have these two multiplied together. So we're going to say that u is equal to sin x to the power of 2 like this here. So du over dx is going to be, so we have to use the chain rule because we have the inner function, which is the sin x, and the outer function, which is power of 2 here. So when we differentiate this, it's going to be the inner function differentiated, so sin x differentiated, which is going to be cos x, and this is multiplied by the outer function differentiated, so this power of 2 here. So this power of 2 is going to come down as a coefficient. Remember, we don't change the sin x when we're differentiating the outer function. This is still going to be sin x, and then this is going to be to the power of 2 minus 1, which is the power of 1, but we don't really write this. And then we can simplify this to 2 sin x cos x, like this here. So therefore v is going to be the cos x to the power of 2. So therefore dv over dx is going to be the inner function differentiate, which is cos x, which is going to be minus sin x, and this is multiplied by the outer function differentiated, which is this power of 2 here. This power of 2 is going to come down here, so it's going to be 2 cos x, and it's the power of 1, but we don't write this, and we can write this as minus 2 sin x cos x. So we have du over dx and dv over dx. dy over dx is going to be u multiplied by dv over dx, so minus 2 sin x cos x multiplied by sin x squared. So this is going to be minus 2 sin to the power of 3 x, as we've got sin x to the power of 2, and then sin x here, and then cos x. And then it's going to be plus v multiplied by du over dx. So 2 sin x cos x multiplied by cos x to the power of 2. This is going to be 2 sin x cos x to the power of 3, like this here. So for the fourth one, we have y is equal to minus 7e to the power of x to the power of 2 multiplied by x squared minus 1 to the power of 5. So we need to use the product rule. So this here we'll say is u. So u is equal to minus 7e to the power of x to the power of 2. Therefore du over dx is going to be equal to, so this minus 7 is going to come down here, and this is multiplied by, so we need to use the chain rule for this here, with the inner function being this x to the power of 2 and the outer function being this e to the power of. So the inner function differentiated is x squared differentiated, which is 2x, and this is multiplied by the outer function differentiated, which is going to be this e to the power of a function. Remember, when you have e to the power of something, when you differentiate it, it is still just that e to the power of something. It has no effect. So when you differentiate the outer function, it's still going to be e to the power of x to the power of 2, like this here. And then we can simplify this. 2 times minus 7 is minus 14. So du over dx is minus 14x e to the power of x to the power of 2. And then we'll say that v is equal to x squared minus 1 to the power of 5. Therefore dv over dx is equal to, so the inner function differentiated is x squared minus 1 differentiate, which is just 2x. This is multiplied by the outer function differentiated, so this 5 is going to come down here, so it's 5. Then x squared minus 1, this stays the same, and now it's going to be 5 minus 1, so it's now to the power of 4, and then 2 times 5 is 10, so it's going to be 10x, then x squared minus 1 to the power of 4. Then dy over dx is going to be u multiplied by dv over dx, which is going to be minus 7e x to the power of 2 times 10x x squared minus 1 to the power of 4, and then v multiplied by du over dx, which is going to be x squared minus 1 to the power of 5 times 14x e to the power of x to the power of 2. And there's a lot of simplifying we can do here. Minus 7 multiplied by 10 is minus 70, and then we move this minus 14 to the front here, so it becomes like this here. So therefore this here is dy over dx. So here's one final example where we have multiple terms. I've talked about this before. When you're doing multiple terms, you just differentiate each term individually. And I've also talked about this before. Make sure that you do it one term individually. Don't try and do it all at once really quick, or you're going to get overwhelmed. Do it one term at a time and one step at a time. So let's focus on this term first, the natural log of x squared. Now you might be thinking to use the chain rule here, but you don't need to, because, I mean, you could do it that way, but the easier way to do it is to use the laws of logs and realize that the natural log of x to the power of 2 can be written as 2 of the natural log of x, because remember, when you have a power of 2 like this, it can come down to the coefficient here. And then if you differentiate this here, this is very simple, so we have this 2 at the front, so it's just going to be 2 multiplied by, and then the derivative of the natural log of x is 1 over x, and this can be written as 2 over x. So this is the natural log of x squared differentiated. And then let's focus on the next term, which is the x to the power of 3 multiplied by x minus 1 to the power of 3 over 2. So we need to use the product rule. So we'll say that u is the x to the power of 3, so therefore du over dx is going to be 3x squared. So then v is going to be the x minus 1 to the power of 3 over 2. So dv over dx is equal to, so the inner function differentiated, so the inner function, this is x minus 1, and this differentiated is just going to be 1, because it's going to be x differentiated, which is 1, so it's going to be 1 multiplied by the outer function differentiated, which isn't going to have an effect. So we just do the outer function differentiated, which is this power of 3 over 2, so this comes down as the coefficient. This here is still going to stay as x minus 1, and now it's going to be to the power of 3 over 2 minus 1, which is a half. So therefore, if we differentiate this whole thing here and use the product rule, it's going to be u multiplied by dv over dx. It's going to be 3 over 2 x to the power of 3, and then the square root of x minus 1, as the indices of a half is the square root. And then it's going to be plus v multiplied by du over dx, which is going to be 3x squared, and then x minus 1 to the power of 3 over 2. So dy over dx, we just add the terms together and do it all at the end. So it's going to be dy over dx is going to be the natural log of x squared differentiate, which is 2 over x, plus this differentiated, which is 3 over 2 x to the power of 3, the square root of x minus 1, plus 3x squared x minus 1 to the power of 3 over 2. Now, I've talked about this in all of the videos in this chapter so far, so I'm only going to go through it quickly here. For a more detailed explanation on this, go back to the first video in this chapter, titled Differentiating Sin, Cos, Exponentials and Logarithms, but I want to mention it here too. There's a really good way to check your answers to differentiation questions in an exam by using your calculator. So on your calculator, if you press shift and then this integration symbol here, you get this differentiation term, and if you put in the y value that the question wants you to differentiate, so let's for example do the question that we just did, so this y value here, so put this expression into the calculator. You can get x terms in by using this x button here, and then if you put in a random value here for this x equal part, let's just say 5 for example, and then you put this into your calculator gives out a value of 975.4. What this is your calculator differentiating this expression here and then subbing in the value of x is equal to 5. And then what we can separately do is sub in the same value of x, so x is equal to 5, into the derivative that we got out, that we figured out on our own. So that's what I've done down here. I've subbed in x is equal to 5 as the x values for the derivative that we figured out ourselves. And if you put this into your calculator, this here, this also gives out the value of 975.4. And if these two numbers are the same, this tells you that this expression here that you've got out for the derivative is correct, and you've got the correct answer. Because this number here is the calculator differentiating this expression here and subbing in x is equal to 5. And this number is you subbing in x is equal to 5 in the derivative that you figured out on your own. If these two numbers are the same, this tells you that you've got the correct answer. Now, you can't just use this to solve the question for you because it can't give out this expression here. But what this is very good for is checking that you have got the correct answer to the question by seeing if these two numbers are the same. If these two numbers are not the same, if they're two different numbers, this tells you that in your working out you have done something wrong and you need to go back and check where you've made the mistake. But if these two numbers are the same, you know you've done all your working out and you can confidently move on to the next question knowing that you've got the answer right. I just also want to mention one more thing. In the chain rule video, I talked about how you could do the chain rule the long way by substituting in u and then doing du over dx and stuff like that. But I said a quicker way, like we've done in this video, is just to think of it as the inner function differentiated multiplied by the outer function differentiated. Again, go back to the chain rule video if you need to for a reminder on that. For the product rule, I would always recommend labeling something as u, something as v, and then figuring out du over dx and dv over dx. I wouldn't try and do it a quicker way, just because I think there's more mistakes you can make with the product rule. So write down the u and v, do the full steps, and avoid making any silly mistakes. So for the rest of this video, I'm just going to go through some past paper questions on the product rule. So here's an example of this. So for part A, we need to differentiate e to the power of 3x multiplied by sin x plus 2 cos of x. So we're going to use the product rule here because it's e to the power of 3x multiplied by this bracket here. So what we're going to do is we're going to say u is equal to the e to the power of 3x part, and then we've got du over dx is equal to, and then we differentiate this, it's going to be 3e to the power of 3x, and then we're going to say that v is equal to this here, so v is equal to sin x plus 2 cos of x, and therefore dv over dx is equal to, so if you differentiate sin x, it's equal to cos x, and this is going to be plus 2 multiplied by cos x differentiated, which is minus sin x, and of course this can be simplified to cos x minus 2 sin x. So therefore dy over dx is going to be u multiplied by dv over dx, it's going to be e to the power of 3x multiplied by cos x minus 2 sin x, and then this is going to be plus v multiplied by du over dx, which is going to be 3e to the power of 3x multiplied by sin x plus 2 cos of x. You could simplify this further by factorising out the e to the power of 3x, but you don't need to. It doesn't say it in the question. You get all of the marks just by writing it like this. And then for the second part, we have x to the power of 3 multiplied by the natural log of 5x plus 2. So we'll say that u is equal to x to the power of 3. So therefore du over dx is equal to 3x squared, and then we'll say that v is equal to the natural log of 5x plus 2. So dv over dx is equal to, so we need to use the chain rule with the inner function being the 5x plus 2 and the outer function being the natural log. Now when you differentiate the inner function, you get this 5x here becomes 5, so that's the inner function differentiated, multiplied by the outer function differentiated, which is this natural log here, which will become the 1 over fraction. So remember that this stays the same, so it's going to be 5x plus 2 under 1 like this here. When you do the natural log, it becomes 1 over, and then you can move this into the numerator, so it becomes 5 over 5x plus 2. So therefore dy over dx is going to be u multiplied by dv over dx, which is x to the power of 3 multiplied by this, which will be 5x to the power of 3 over 5x plus 2, and then plus the v times the du over dx, which will be 3x squared, natural log of 5x plus 2. So here's some final examples of past exam questions that they've asked on the product rule. So pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for question 1, we're told that y is equal to x and then 2x plus 1 to the power of 4, and we need to show that dy over dx can be written in this form here, where we need to find n, a, and b. Okay, so to differentiate this here, we need to do the product rule, because it's x multiplied by 2x plus 1 to the power of 4. So let's say that u is equal to x, and therefore du over dx is going to be x differentiated, which is just equal to 1, so therefore v is going to be equal to 2x plus 1 to the power of 4, so therefore dv over dx is going to be equal to, so we need to use the chain rule here with the inner function being 2x plus 1 and the outer function being this power of 4 here. So the inner function differentiated is going to be just 2. This is multiplied by the outer function differentiated, which is this power of 4 here. So it's going to be, the 4 is going to become the coefficient. We've still got this 2x plus 1 here, but now it's going to be to the power of 4 minus 1, which is 3, and then 4 times 2 is equal to 8. So dv over dx is equal to 8, 2x plus 1 to the power of 3. So therefore dy over dx is equal to u multiplied by dv over dx, which is 8x and then 2x plus 1 to the power of 3, plus, and then v multiplied by du over dx, which is just 2x plus 1 to the power of 4. However, this here is not in the form that we need it, because we have 2 of the 2x plus 1 brackets here, but we only want 1 present and we want 1 other bracket present. So this is a clue that we're going to want to factorise this, so there is only one 2x plus 1 present, which is going to be at the front. And the other clue is that 2x plus 1 is present in both of these terms. It's present here and it's present here. So what we can do is we can factorise out 2x plus 1 to the power of 3. So from both of these terms, this one and this one, we can factorise out 2x plus 1 to the power of 3. So if we factorise 2x plus 1 to the power of 3 from this here, this whole one is just going to go away to just leave us with 8 x, and if we factorize out 2x plus 1 to the power of 3 from this here, this 4 is going to convert to a 1. So it's now going to be 2x plus 1 to the power of 1 like this here, and then 2x plus 1 to the power of 1 is just 2x plus 1 like this. So now we've got this 2x plus 1 to the power of 3 here, and we've got this 8x plus 2x plus 1, and 8x plus 2x is 10x. So therefore we've got 2x plus 1 to the power of 3, and then 10x plus 1, which is in the form that we need it, with this n here being 3, this a here being 10, and this b here being 1. Okay, so for question 2, we're told about the curve with the equation here, which is shown here. And for part A, we need to find the coordinates of the point where it crosses the y-axis. So this is going to be this point here. And this is going to be when x is equal to 0. So we need to find the y-coordinate when x is equal to 0. So just sub x is equal to 0 into this equation here, which is what we've done here. And then if you put this into your calculator, you get out a value of y is equal to 2. So the coordinates of the point where c crosses the y-axis is 0, 2. Okay, so for part B, we need to show that C crosses the x-axis at x is equal to 2, and we need to find the x-coordinate of the other point where C crosses the x-axis. So it crosses the x-axis when y is equal to 0. So here, so what we need to do is we need to equal y is equal to 0 in this equation here and solve it. So this is going to make it 2x squared minus 5x plus 2 times e to the power of minus x is equal to 0. And as e to the power of minus x cannot be equal to 0, anything to the power of something cannot be equal to 0, we can divide both sides of this equation here by e to the power of minus x, so we can get rid of e to the power of minus x on this side. So it just becomes 2x squared minus 5x plus 2 is equal to 0. And then we can solve this by solving the quadratic. There's loads of ways you can solve the quadratic. You can just factorize it here, which it becomes x minus 2, and then 2x minus 1 is equal to 0. So it's x minus 2 is equal to 0, so therefore x is equal to 2, which is the one that they give us that we need to show. And the other one is going to be when 2x minus 1 is equal to 0. So 2x is equal to 1, so x is equal to a half. So the other x coordinate is x is equal to a half. Okay, so for part C, we need to find dy over dx, so we need to differentiate this, and because we've got this multiplied by this, we're going to use the product rule. So we're going to call this here u, so we're going to say u is equal to 2x squared minus 5x plus 2, so therefore du over dx is equal to 2x squared differentiated is 4x, and then 5 minus 5x differentiated is minus 5, so that's du over dx. Therefore v is going to be equal to e to the power of minus x, and dv over dx is therefore going to be, so this minus is going to come down, so it's going to become minus e to the power of minus x. We talked about this in the first video in this chapter. So therefore dy over dx is going to be equal to 2x squared minus 5x plus 2 multiplied by minus e to the power of minus x, and then we can just move the minus to the front here, and then it's going to be plus 4x minus 5 multiplied by e to the power of minus x. Okay, and for part D, we need to find the exact coordinates of the turning points of C. And we talked about this in year 1. Turning points exist when dy over dx is equal to 0. So we found dy over dx in part C. We're going to equal this to 0, and then we're going to find the x values for which this equation can be satisfied. So this is what we've done here, and we have e to the power of minus x present in both the terms, so we can factorize this out here. And because, like before, e to the power of minus x cannot be equal to 0, we can divide both sides by it and get rid of it, so we're left with this here. I've also expanded this minus here, so it's now minus 2x squared plus 5x minus 2 instead, like this here. So we can simplify this. 5x plus 4x is 9x, and minus 2 minus 5 is minus 7. So we have this quadratic equation here. I'm just going to multiply everything by minus 1 to get rid of this coefficient in front of the x squared here, this minus coefficient. So that can be a bit difficult to deal with. So we have 2x squared minus 9x plus 7 now is equal to 0. And then we solve this quadratic equation. I'm just going to factorize it. And if you factorize it, it's 2x minus 7 and x minus 1 is equal to 0. Go back to the quadratic videos, you need a reminder of how to solve quadratics. And therefore it's going to be 2x minus 7 is equal to 0. So 2x is equal to 7, so x is equal to 7 over 2, and then x minus 1 is equal to 0, so x is equal to 1. So we figured out the x values, but it specifically says it wants the coordinates, so we need to find the y values as well, and we can do this by subbing the x coordinates back into the original equation in order to find the y values. So if we start with 7 over 2, we sub in x is equal to 7 over 2 into the equation, like we've done here, and if you figure this out, you get out that y is equal to 9e to the power of minus 7 over 2. So therefore the coordinates of this turning point are 7 over 2 and 9e to the power of minus 7 over 2. The mark scheme says it's fine to leave it in this e form here. And then we sub in x is equal to 1 into the equation like we've done here. And if you figure this out, this gives out y is equal to minus e to the power of minus 1. So therefore, the other turning point coordinate is 1 and minus e to the power of minus 1. And those are the two final answers.